There was an idea to have an extremely rapid expansion of space just a few months after our universe came into being, and it gave rise to the real multiverse of madness. Surprisingly, we do have some idea as to what might have been there before the Big Bang. And no, not a singularity. The idea of having an initial singularity comes from general relativity, and we know it isn't complete, and hence its predictions to arbitrary high energies and extreme length scales need not be taken seriously. So what do we know? Well, we know that the universe in the very past was much hotter and denser, and its evolution from this extreme state to how we see it today is what the Big Bang is all about. However, this Big Bang model still had some inconsistencies. When we look out in the universe, distant regions that are extremely far away coincidentally have almost the same temperature, which is not something that you would expect, unless in the far past those distant parts of the universe were closer together. And even though the Big Bang model predicts the universe to be closer and smaller in the past, it doesn't provide them with enough time. This problem was later dubbed the horizon problem. And there were some other problems like the missing magnetic monopoles or the apparent flatness of the observable universe. But apparently, a strange tweak can fix them all. That strange tweak was cosmic inflation. It was something that made our newborn universe expand exponentially for a tiny fraction of a second. The main premise is that before the Big Bang and this cosmic inflation, the universe was small enough for today's distant regions to be in close proximity and hence similar temperatures. But what could have caused such an extreme expansion of space? Well, today's universe is dominated by something we call dark energy. This energy is thought to be filling up all of space, and when we have such an arrangement of energy, general relativity tells us that the resulting gravity is repulsive. So yes, dark energy is basically gravity. And similar to how dark energy is pushing our universe today, there was a time before the Big Bang when the universe was also filled with a similar kind of substance that had energy big enough to cause this exponential expansion of space. We call it the Inflaton field. This exponential expansion of space, though, left the universe in a state of extreme cold and emptiness, which was nothing like how we envisioned the Big Bang. Those hot and dense conditions of the Big Bang were achieved through the process of reheating. This was when the Inflaton field started decaying to its vacuum state, giving out energy into what would ultimately make up all of the particles of the standard model, leaving behind a universe so hot and dense that we often connect to the initial conditions of the Big Bang. The Inflaton field vanished into nothingness, marking an end to inflation, and a normal Hubble expansion took over, until some many billions of years, after which dark energy grew strong enough to push the universe's expansion rate faster and faster again. But that's a story for another day. So inflation can be thought of as the background that gave the conditions that were necessary for the Big Bang. Now, here's the twist. The thing about inflation is that it should go on forever. There is no way you can have a patch of space inflating and suddenly in all of space inflation spontaneously halted. This is just going to be too big of a coincidence. Rather, what may be the case is that inflation is a lot larger and most likely eternal, with an end to inflation only an end in the region of space that marks our universe. But there would be a grander universe in which inflation is still happening, and then what you can have are distinct regions where inflation stops, but on a larger level, inflation turns out to be the most dominant state of the universe. The reason this must be the case is because, much like everything else, the Inflaton field is also subject to quantum fluctuations. And so, while the field is decaying, there can be fluctuations that can momentarily shift the potential of the field by some amount. And so what you get are slight delays in different regions for the Inflaton field to decay, which may not seem significant. However, we cannot forget how fast inflation actually is. Even tiny moments of delays can render that part of the universe extremely big in size. And since there's no end to these quantum fluctuations, there's no end to these inflating regions that will always be able to find some way out of decay. These fluctuations are also thought to be the cause of tiny inhomogeneities that ultimately led to the formation of structure and galaxies in the universe. And so at the largest level, what you get is a fractal consisting of different regions. an infinite fractal of eternally inflating multiverse. Because of how fast inflation is, those regions where inflation stops would most likely be forever disconnected to most of the other regions where inflation actually stops, with potentially different laws of physics and universal constants, all existing in a grand multiverse, where everything that could happen would be happening somewhere. But with the potential of having different laws of physics, the idea of what's even possible may not hold meaning. And that's eternal inflation for you. With what we call the Big Bang being an event by which inflation stopped in our part of the universe, multiverse. Thanks for watching. Bye.